This course will describe the various methods of producing direct current, or DC, electrical power. An understanding of these DC sources of electrical power will be essential for understanding future electrical science and other topics. These are the objectives for this course. When most people think of direct current, or DC, they usually think of batteries. However, in addition to batteries, there are other devices that produce DC which are frequently used in modern technology. A battery consists of two or more chemical cells connected in series. The combination of materials within a battery is used for the purpose of converting chemical energy into electrical energy. To understand how a battery works, we must first discuss the chemical cell. The chemical cell is composed of two electrodes, from Greek words meaning route of the electricity, made of different types of metal or metallic compounds, which are immersed in an electrolyte solution. The chemical actions which result are complicated and vary with the type of material used in cell construction. Some knowledge of the basic action of a simple cell will be helpful in understanding the operation of a chemical cell in general. In a cell, the solute in an electrolyte is ionized to produce positive and negative ions, as shown in the diagram. Simultaneously, chemical action causes the atoms within one of the electrodes to ionize. Due to this action, electrons are deposited on the electrode, and positive ions from the electrode pass into the electrolyte solution, as shown. This causes a negative potential on the electrode and leaves a positive potential in the area near the electrode. The electrolyte solution is a conductor for electron flow. The positive ions, which were produced by ionization of the electrolyte, are repelled to the other electrode. At this electrode, these ions will combine with the electrons. Because this action causes removal of electrons from the electrode, its potential becomes positive. A generator consists of a coil and a magnetic field. When the coil rotates in the magnetic field, a voltage output is produced, as was previously described in the module on magnetism and magnetic induction. Since generators are used to produce either AC or DC current, one DC source is a DC generator. Generators will be discussed in more detail in a later module. A thermocouple is a device used to convert heat energy into a voltage output. The thermocouple consists of two different types of metal joined at a junction, as shown in the diagram. As the junction is heated, the electrons in one of the metals gain enough energy to become free electrons. These free electrons will then migrate across the junction and into the other metal. This migration of electrons across the junction produces a voltage at the terminals of the thermocouple. Some of the metal combinations used in the makeup of a thermocouple include copper and zinc, iron and constantan, copper and constantan, antimony and bismuth, and chromel and alumel. Thermocouples are normally used to measure temperature. The voltage produced causes a current to flow through a meter, which is calibrated to indicate temperature.
Hi, welcome to the Analog Device.
The photoelectric effect converts energy from a light source to electricity by transferring the energy in the light to the orbital electrons of an electrode. This type of device is called a solar cell or photovoltaic cell. A photovoltaic cell uses two dissimilar semiconductors joined together. When the light strikes one of the semiconductor materials, the energy released by the light causes free electrons to cross the junction to the other semiconductor. A solar cell uses photovoltaic cells as primary cells to keep a storage cell charged. When voltage is produced by pressure, it is called piezoelectricity. It is produced by compressing and decompressing crystals of certain substances. In a crystal, the molecules are arranged in an orderly and uniform manner. Quartz is an example of the type of crystal used. When quartz is compressed, electrons tend to move through the crystal. This movement creates an electric difference of potential between the faces of the crystal. If the pressure is held constant, the electron flow will continue until the charges are equalized. Static electricity is commonly caused by friction, such as when one material moves against another material. Friction causes the outer electrons of the surface atoms of one of the materials to be stripped off, creating a negative charge or voltage. This occurs in clouds, causing lightning, or other materials causing a static charge. Most electrical power generating stations produce alternating current, or AC. The major reason for generating AC is that it can be transferred over long distances with fewer losses than DC. However, many of the devices which are used today operate only or more efficiently with DC. For example, transistors, electron tubes, and certain electronic control devices require DC for operation. If we are to operate these devices from ordinary AC outlet receptacles, they must be equipped with rectifier units to convert AC to DC. In order to accomplish this, we use diodes and rectifier circuits to convert AC power to DC. The most common type of solid-state diode rectifier is made of silicon. The diode acts as a gate, which allows current to pass in one direction and blocks current in the other direction. The polarity of the applied voltage determines if the diode will conduct. Recall that an AC current periodically changes direction, whereas a DC current flows in only one direction. Since the diode only allows current flow in one direction, an AC current applied to a rectifier circuit produces a DC current.